To be or not to be? To be or not to be? Так. Something. To be or not to be?
Правда, что себя бояться, то что практику есть
Ничего.
позвонил.
Оформить тут же юридически надо.
Да, он не знает. Уже еще начальство может сказать.
А я думаю, что начальство HR будет слушать. Так. Let me in. Let me in. Let me in. Is
Что это за АСТ, одна цифра, например, какая-то помеченность с языком появилась? Я помню, раньше в магистратуре вот больше практику проходить, сейчас потому что язык все один себя просит сертификат. Ну, такие позиции, типа электронадзора и прочее.
там опять в HR набрали. Так, обе. Ношение слова. А, не. 0 viewers.
No one wants to listen.
It's alive. It's alive, it's alive. What I have for today, I would like to show example of device with quite serious, I would say, shift towards analog signal processing part in its path. 1 second, I'll open document I needed. Document. Oh, here is one document. One moment, please. Great. Oh, yeah. Yeah. It was. This device is a diploma work of one of our students. What it is? It's an angular sensor with control system. What's inside? 1 second, let me. Tilt. I can look here. It's a sensor of position of angular differentials, idea of differential sensor. If you have two coils, pair of coils, and magnetic core, independence of coil position, there will be a difference in coils inductance. You can use, for example, like this bridge. What's inside here? Okay, we can skip this difference. If we need to measure angle, we can use what? Or swing like magnetic system with central excitement coil and side sensor coils, or something like arc, or some more like this. Of course, we can use encoders, but encoders are hard to survive in that environment. All kind of encoders. What's here? Different design. Traditional inductive sensor will have solid core, excitement coil, and sensor coils. But we can use not only solid magnetic body, we can use magnetic fluids. What it kinds? It's carrier fluid filled with very thin particles of magnetic conductive material. The carrier fluid is designed in special way to, how to say, to get wet, to form a stable kind of, it's not alloy, it's a kind of solution. On the one hand, it's a fluid, it's liquid. On the other hand, it's magnetically conductive. Composition, jet fuel, surface active agents, some kind of oil to make it more not so liquid, and some manufacturer specific components to prevent forming a cloth. On the one hand, it fully covers surface of magnetic particles. On the other hand, it prevents clogging. They do not mix in one big chunk of magnetic fluid. It's a very special structure with surface active parts, filler, and parts preventing clogging. Blah, blah, blah. Short story. So, let's go forward. Sensor idea. Here is one of the ideas of kind of sensor. What it have? Tube or some vessel with magnetic fluid, excitement coil, and set of sensor coils. Idea with tilting of this vessel, magnetic conductivity will change because amount of fluid at each end will change. Okay, here is composition of this fluid. What we have, ferrum chloride, ammonia, and as a fuel, again, jet fuel. Here, fresh magnetic fluid in magnetic field. Bridge, ideal bridge, 2 coils. It's a sensor bridge. Here, response how to say, it's not a response, it's appeared magnetic inductivity as a frequency of frequency. This blue line without magnetic fluid, purple line with magnetic fluid. For test, generator, bridge, voltmeter, balancing and sensor. Let's go forward. It's first prototype. Tested in it's in Salaspils in physics laboratory tested. Now our one, let's go forward. We knew what it's yeah, this one. This schematics. Remove diodes, and what we see, it's a second order filter put in the positive feedback. It's so-called wine bridge. Idea what this without diodes it will be unstable on non-frequencies except one particular frequency of bridge balance. This circuit is a limiter. It's use non-linearity of the diodes. As a result, this thing is a source of sine wave signal. It oscillates with sine wave. We since we do have two arms, 2 coils balancing, our signal will be what is usable part of signal here? Usable part of signal is difference, unbalanced. When both arms are ideally balanced, inductance is of them, inductive resistance of both arms will be same. Both both shoulders will be equal. Bridge will be in balance, and there will be no output signal at all. In ideal case, if the bridge is not in balance, we will see difference. This difference can be amplified with differential amplifier. in case simple differential amplifier is good, but here we need one more, and this one more is what? We need to suppress noise, because noise from the network, from close electrical equipment and so on, will affect both coils in the same way. If we wide differential amplifier, if we take as a usable signal difference, we will have A minus B as usable signal, let's say A and B shoulder, but noise will affect both shoulders in the same way. If we have, let's say, some kind of Xi noise, A will be plus Xi and B will be plus Xi. Yeah, additive noise. Since our signal is A minus B, Xi minus Xi will produce 0. Such schematics of differential amplifier suppresses so-called same phase or same phase noise. Okay, here is sensor itself, real. Yeah, it stands. Maybe I can switch my camera on. One moment. I'll bring sensor closer. Here it is. Sensor. It's a closed vial from it's made from PMMA, filled with magnetic fluid on half of the I'll say half of the volume is magnetic fluid, and here on the left and on the right are pair of coils. Let me go back to my word. Oops, come on. Here is magnetic field modeled it with quick field software. Horizon balanced, so in horizon here under angle. You see difference in magnetic field. Here is approximate current difference, current in microamps. It's located on angular platform. Precision chart. And now schematic of this device. Here is schematic of my device. That's why I'm here. What we got here? It's a schematic of analog part. What is device? Now it's an angle measure. Now, how it works? What we got here? Schematics. What's this? Okay. What it now? Here is a wheel with magnetic fluid. Excitement coils and actually it has only two coils. They are in the shoulders of the bridge. Oh, come on. It acts as an angle sensor. Also, you see, it sends warning signals. It's intended to be an angle sensor. How it works? Our true signal is liquid always stabilized horizontally. So if there is a difference between surface of the liquid and axis of the wire, it will produce signal. So this signal is processing by this analog part. Then it's taken FX for AD. AD means analog to digital. This model is analog to digital and ADC, analog to digital converter. Brain, microcontroller, and indication we have nice drone meter. Can you see it? It shows angle in degrees. Also, output warning too high. Too much to the right. Too much to the left is set. Here on the screen is a schematic of analog part. Big design here. Design is influenced by speed characteristic of analog to digital converter. It's relatively slow. So most processing of signal done in analog part. Digital part and logical are relatively simple. It's an old school when key payload is done in pre-processing part, not the main processing. And what's going on here? Let me explain these schematics. 1 second, I will switch for my online viewers. 1 second, I'll switch to this. Here, first part. This. What can it be? Transformer. Enlarge. Transformer, diode bridge. Pair of capacitors. Something familiar from electronics? This part. Familiar? What's this? Split power supply, plus minus 12 or something like this, or 14 volts. So this part is a split rectifier, plus the ground or zero minus, symmetrical. It's a split rectifier with pair of capacitors as filter. Next one. Here should be Zener diode. PNP and PN. You can see they are mirrors. What these are? Simple electronic stabilize. From 12 or 14, something like this, volts, they produce stable plus 10 and minus 10 for powering of operational amplifiers. This part clear? Maybe I can enlarge. Simple split power supply. Plus 10, minus 10 with stabilizers. Oh, disappeared. Next part. This one. What we see here? You see second order filter put in positive, see this plus, positive branch of operational amplifier. This one is oscillator or auto generator. If you take a look on negative path, take a look. These two, if there were no diodes, these two would define what? Ratio of amplification, yeah? Do you have knowledge about operation amplifiers? You heard something. Without anything, it's some kind of 10,000 or I don't know, 1 million multiplied by difference V plus V means, yeah? If you put in negative branch this pair of resistors, ratio of amplification will be ratio of these resistors. Yeah? Yeah. This one branch added using non-linearity of diodes, because diodes do have non-linear part at the beginning of their forward branch. This pair of diodes is used as a logarithmic limiter. Commonly, this one is a generator of sine signal. Repeater, this tiny guy is repeater, and where it goes, we have two branches, one after repeater and one goes here. It powers, these connectors are coils, and here in center is balancing resistor. These two amplifiers, two amplifiers, something familiar? Yeah, or not? These two guys are forming what? Differential amplifier. We need, on the one hand, usable signal is a non-balance of bridge. What forms bridge? Coil, here one coil, here another coil, resistors. Our bridge looks like, yeah, this. Coil 1, coil 2. 2217. This is 17. This is 22. Ground. AC source. And this go to differential amplifier. Lower resistor. Where are you? Oh, this tiny resistor is used for balancing. actually it's a zero adjustment. Usable signal is voltage. Very fine. Next one. What about this part? Familiar something, not? Our previous lecture. Oh, you're missing. Nice sensor. What this part is? Our previous lecture. It's a Sallen-Key filter. This part is Sallen-Key filter. It cuts off high frequencies noises. It cuts everything above frequency of our oscillator. Sallen-Key filter. This part is something you see in first time. Look what this. We have via repeater signal of my sine generator. Here goes usable signal. Here FET, filter emitting transistor, is driven by signal from the oscillator. You know what this? Have you ever heard about synchronous detectors? It's one of the examples of synchronous detector. Synchronous detector, key idea. If you have S1 as, say, cosine omega t, and x2 as a cosine omega t plus alpha, if you create a product equal S1 multiplied by S2, where is my trigonometric table? What is cosine alpha, cosine beta? Multiply. Product of two cosines should be plus, minus, and key element, DC component, or it is okay. Amazing. In case we have sine alpha, sine beta, the product will be cosine alpha minus beta plus, minus cosine since alpha is omega and beta is omega t plus some angle phi, what we will get? One will be cosine, this one will produce us double omega t component, and this one will produce omega t minus omega t plus alpha minus cosine phi. That's what we're looking for. Think if you multiply signals from two coils, you will get signal output with two components. One with double frequency, and second one cosine of shift between them. Here, take a look. It's brutally because we will cut off for all high frequencies. Signal for which to multiply is converted into rectangles with this fat. Looks brutal, but because rectangles are on frequency plus 1/3 of the triple, everything useless part will be at 6 omegas. It will be removed by this low pass filter. Here, simple impedance correction amplifier and output, because this analog to DC ADC converter is intended for range 0-10 volts, typical for automation. We get something very usable. Next part converted into relative value and represent in degrees, because we know, as you show it, we know characteristic. Now, what can I do? Look how it can be used in what's up? I can it was stupid. Once more. Signal processing path. Differential amplifier. These two operational amplifiers is a differential amplifier. This part, silent key filters filter to remove high frequency components noises. This one, synchronous detector, where differential voltage is multiplied with the signal of the excitement generator. Then low pass filter cuts double frequency components and This one is our output amplifier. Now, take a look. It disappears. What's this? Oh, appears. It's stupid. Okay, where I want to be? I would like to show how it works. This one we see. So it's operation in angular sensor mode. But this thing can also act differently. Wheel is attached to the drive. If I tilt come on. Once more. Correction. It uses pulse control. If angular difference is high, it sends long pulses to drive. When it's self-level. One more correction. Oops, stands. Self-level. Try to forward. Oh, it's leveled. Oops, leveled. Okay, what we see here? Funny toy. But what behind? What do? What kind of lesson can we learn from this? Here we have example of design where most of the signal processing is put on analog part. Logic here, very simple. Compare one value to 0. Logical part is simple. Analog to digital conversion part is very simple. It has one signal for DC from 0 to 10 volts. It's very typical for industrial automation. Most popular, of course, is 420 milliamps. No standard industrial analog error signals. Thousands and thousands of sensors where you have at input something like pressure, temperature, I don't know, volume and so on. Output is for 0 to 10 volts proportional here X signal or Y, where 0 is 0 and maximum possible is 10 volts. From 0 to 10, or most popular are version where you have the same proportional value, but this is current, and 0 of X of input value corresponds to 4 milliamperes, and max corresponds to 20 milliamperes. Most popular way to all kinds of small sensors can give you info. Why not 0? Because the 0, this part is reserved for loop fault. If you see value lower than 4 milliamps, you have loop fault. This ready-made analog to digital converter is slow and it can operate in both modes, but it's intended for slow process like pressure, I don't know, water flow.
How does it look like the loop fault? The loop fault, how does it look like?
Interruption, wire interruption, or sensor failed, or supply of this chain failed. Outside 420, signal should be discarded. It's a fault. You should indicate an error. If below 4 milliamps, you have loop fault. If above 20, you have shortcut.
Something goes out.
Not good. It's even steps. If difference is high, controller sends long in signal. In small difference, it sends pulses. Pulses to make a small increments. It's a limitation of drive. Because drive has only one speed. Level yourself. Level yourself. Stands. Okay, it's a funny toy. But again. Power supply, signal generator, buffer, differential amplifier, silent key filter, synchronous detector, low pass filter, one more, and for amplifier. Actually, it's near the high end of power systems automation pre-processing. In the lowest end, simple low pass filter and nothing else. All processing is done numerically. Another end, numerical part is nearly pure logic. Only simple analog to digital conversion. But all processing of signal is done in analog part. The lesser processor resources you have, the older your processor or smaller your budget on digital part, the more burden will go to the analog pre-processing. You cannot fully abandon analog part. You will need power supply for analog part. You will need kind of amplifier and most. Anyway, you need to suppress frequencies above Nyquist frequency. It's a must. It cannot be avoided. That means that you cannot fully abandon analog pre-processing, but it will remain with you. One more point I would like to finish with this analog pre-processing. One more point. Sometimes you need a very specific thing. You need to suppress one of the frequencies.
What's the point of small, like the budget on components?
Point is what? Performance of digital part. It's sum of microprocessor performance, your DSP processor performance, and ADC performance. When you have slow, relatively low capacity processors, one of the things I just saw one tricky device. Designers tried to minimize costs. They use central processor from original designed for scales, these trading scales. It's slow and relatively stupid because there is no need for speed on scaling. You just put something and you can wait a couple seconds while reading stabilize. They did, I don't know what was the driver behind it, but all other part is adjusting to this small slow processor. Where in early days, I saw days when first digital signal processing became available. They were with so small capabilities, what operation current multiplied by resistance were done in analog part with trans reactor. Simple, not one more moment. It's in ideology. When you reach, you can say you have in reality you will have multiple channels, voltages, currents, so on. When you have a good budget, you can assign own signal processor for each channel. When your budget is limited, you will have sequential service scheme. When one channel is serviced in one time moment, servicing part switch multiple exit. Signal, you will see priority key signals like faulted or how to say protected line voltage currents are in priority. Secondary priority like transformer temperature or motor temperature, it's with high inertia, it can be serviced in second priority. Or for example SF6 LGS pressure in your switch, or switch temperature, or supply circuit voltage, they are second priority. And second priority signal, you may find at one moment that you don't have budget. You spend your performance budget on first priority. You don't have enough budget for second priority. What you do? You perform processing of second priority in analog part, just for in ultima way. What will happen? In ultima way, if you have only to be within limits, you can process everything about this channel in analog part and only take binary signal, okay or not okay. Only fully unloading your processor. For example, supply voltage. You need to monitor the supply voltage. What you if power supply of your device falls below, not between, but below safe operation threshold, you will get erroneous operation. It's not permittable. So you need to have signal power failure under voltage. How you do it? If you don't have ability to spend one of the ADC channels to monitor your voltage, you can do what? Simplest comparator, plus minus voltage is compared to reference, is below reference, binary signal under voltage is generated, and that's all. In good designs, signal under voltage leads to emergency safe shutdown. Your device saves current network parameters. Why can be under voltage? We have fault, and this fault affected own power supply of substation. When power returns, you send, or some device send disconnection signal, fault is cleared, voltage returned, your device can go back to operation knowing what was before. It's a good practice. What a stupid. Why am I here? Do we have someone? Oh, we have one viewer. Why? What I'm willing to do, I need to activate this thing. One, two, three, 1, 2, 3. you found. Yeah? This system was in operation a couple of weeks. Now works. Very slow. Okay. Now, next time I will tackle analog to digital conversion. I don't know. 1 to 3, 1 to 3.
Yeah,
It's much. Who counted? Next time I would like to tackle analog digital conversion. What's inside this small box where AD is written? In theory, in short theory, we have analog input, voltage or current, and output as an integer. But what's? I would like to look a bit deeper. Not enough today, it's not enough time. Next. This funny example. One more. If we here, I remember one more. I started to think that this is heaviest pre-processing, but then electrotechnics theory, phasors. Yeah? Electrotechnics theory represents voltage and currents and then phasors. Heaviest analog pre-processing I saw was extraction of phasors in analog part. See, here is synchronous detector producing this part produces cosine of angular difference between voltage and reference. Here is reference, here comes differential voltage, so angular difference between reference and voltage. If you create two reference with 90-degree shift between them, actually you need to split one source generator into voltage with 90-degree, and you perform synchronous detection with both of them. What you will get? Two signals proportional to cosine to one reference and second reference. Meaning what you get phasor, you get angle. And one more channel measures amplitude. Produces DC signal proportional to AC amplitude. This three gives two angles and magnitude. Gives a phasor representation of signal. I saw device with phasor extraction in analog part. And that wasn't all. It was not only simple phasor extractor. More, it performed Fourier analysis. It has set of bandpass filters for. Remember what is Fourier Fourier series? I don't know what about the program. You have electronics in your background. Fourier series. Yeah. Yeah, Fourier transform, Fourier series. So it was device with analog analyzes on Fourier series. Set of bandpass filters fine-tuned for harmonic frequencies. And on each frequency, extraction of phasors. Totally, it has something about 400 synchronous detectors, multipliers, and was a part of it's not kind of aerial data acquisition. All in analog. Numerical part was only logic. put this size. It's description. Done for speed. They perform logical processing on kind of industrial late 80s industrial computer with it's slow and slow ADC slow. So they decided to put full load of spectrum analyzers on analog part. I don't know what about reliability and better don't ask about energy efficiency. 400 multipliers. Okay, it's gone. Okay, so maybe some questions? Orca whale. Hello, whale. What can you tell us about signal processing in analog part? Do you have any questions? Orca whale. Silence. I'm new here, seems very interesting. Yeah, you can check my channel, we are in the middle, of course. Yeah. Today our toy is example of how automation device can work with this one is example of device where key signal processing is done actually in analog pre-processing part. You can see it acts as a self-leveling device. Okay, where I am, what I'm doing, I need to prepare for next class. Okay, if some questions? No? From online, maybe some questions? Yeah, I see interesting. You can subscribe, but follow the captions, because I have multiple courses on my channel. You can take previous year courses, but these courses mostly are theory of signals and power system automation. Sorry, I didn't separate them in playlists. Oh, you can go back in my channel for previous semester. Previous one was better. I have full course of theory of signals and full course of power system protection in previous semester. This I have less English lectures in this semester. I don't know. Of course, you can try to some AI translation tool on Latvian lectures, but I'm not sure it works fine. Okay, I have to finish for today. Next time, analog to digital conversion. Okay, see you next. Today, yeah, welcome.